This video will explore Retrieval-Augmented Generation, or RAG, discussing what it is, how to use it, and the key considerations for building grounded, reliable AI systems. This program is brought to you by the Series of Thoughts team as part of the AI Foundations series. We begin with Chapter 1, the evolution of RAG, marking the shift from closed book to open book AI. Closed book large language models, or LLMs, only know what they memorized during training, leading to a hard cutoff date for knowledge. They cannot access recent or proprietary information, often resulting in confident but incorrect, outdated, or fabricated answers. The breakthrough came in 2020 when Meta AI introduced RAG. This revolutionary approach combined parametric memory, the models learned weights, with non-parametric memory, an external document corpus queried at runtime. This hybrid achieved state-of-the-art results. RAG enables open book AI. Instead of relying only on memorized training data, the model can look up and use external knowledge in real time to generate accurate responses. The core concept of RAG involves 3 steps. First, the system retrieves relevant context from external documents. Second, it augments the LLM prompt by injecting the retrieved context. Third, the LLM generates a grounded, specific, and up-to-date answer. In Chapter 2, we will examine the anatomy of a RAG system and the essential building blocks that make it functional. The 3 key components of RAG are the retriever, which searches the knowledge base itself, an indexed collection of documents, and the generator, the LLM that synthesizes the retrieved data into a coherent answer. Retrieval can be done via keyword search, which is fast but lacks semantic meaning. Semantic vector search matches the meaning and intent of the query. Hybrid approaches combine both for optimal speed and relevance. Indexes, like a library's catalog, are optimized data structures for fast retrieval. Embeddings are numeric vectors that capture the meaning of text, enabling similarity search in high-dimensional space. In practice, RAG starts with a user query. The retriever fetches the top K relevant document chunks. These chunks are used to augment the LLM prompt, which then generates a grounded answer with citations. This pipeline, user query, retrieval, prompt augment, LLM generation, and grounded answer, ensures every response is anchored to source documents, dramatically reducing hallucinations. Chapter 3 covers practical use cases for RAG, showing where it delivers the most real-world value. Use case 1 is enterprise knowledge bases. RAG-powered bots can instantly surface precise answers from internal documents, like manuals and wikis, improving employee efficiency. Use case 2 addresses the need for up-to-date information access. RAG solves the model training cutoff problem by connecting to live or frequently updated document stores, providing accurate, cited summaries of recent events. Use case 3 leverages RAG for domain-specific expertise. It can retrieve latest clinical guidelines in the medical field, surface relevant case law in the legal domain, and access specialized documentation for technical tasks. Use case 4 is hybrid data environments. RAG bridges structured data, like SQL databases, with unstructured documents like PDFs, providing comprehensive answers by combining both sources in a single response. Chapter 4 moves into advanced RAG techniques and challenges, focusing on building production-grade systems beyond basic retrieval. Naive RAG can fail due to 3 issues. Irrelevant retrieval, where noisy chunks confuse the generator. Multi-hop struggles, where complex synthesis overwhelms simple retrieval. And static retrieval counts, which hurt performance for varied query complexity. Chunking strategies are the hidden foundation of RAG quality. Documents must be split appropriately. Chunks that are too small lack context, while chunks that are too large dilute relevance. Overlapping windows help preserve context at boundaries. For multi-hop questions, query decomposition is essential. It splits a complex query into subqueries, retrieves documents independently for each, and then synthesizes the results into a comprehensive answer. Re-ranking and filtering sharpen relevance. After initial wide retrieval, re-ranking models score and reorder results. Combined with heuristics like recency or source authority, this boosts accuracy and reduces hallucinations. Adaptive retrieval pipelines implement smart routing. They dynamically adjust retrieval depth based on query complexity. Simple factual questions can skip deep retrieval, while complex queries trigger multi-hop pipelines, saving latency and cost. Advanced RAG techniques, like re-ranking and query decomposition, deliver significant accuracy gains on complex and ambiguous queries, where naive approaches struggle the most. Chapter 5 focuses on when not to use RAG. Knowing when it's the wrong tool is as crucial as knowing when it's the right one. RAG can be overkill for small datasets where the full context fits in the prompt window, and ineffective for general knowledge or style modification. It's also often outperformed by SQL tools for structured data, or APIs for ultra-low latency, real-time data. A real-world example is a startup with only about 50 pages of documentation. Simple prompt engineering, by stuffing the entire document into context, is better than a full RAG pipeline, offering lower cost, faster speed, and less complexity. Chapter 6 covers deployment considerations and best practices for building RAG systems that are secure, scalable, and production-ready. When choosing between on-premises and cloud RAG systems, on-premises offers better data control but limited scalability. Cloud provides elastic scalability and easier maintenance, but raises potential data governance concerns. Data governance and security are vital. Role-based access control, or RBAC, must be enforced to ensure sensitive or restricted documents are only retrieved and viewed by authorized users. To build a sustainable RAG pipeline, curate your knowledge base with quality data. Choose the right retrieval method, whether keyword, semantic, or hybrid. Crucially, evaluate and tune the system continuously, as RAG quality degrades silently without monitoring. An essential evaluation framework involves 3 steps: assembling high-quality test queries, automating metrics for accuracy and hallucination rate, and isolating variables for controlled testing of components like chunking or retrieval methods. Mitigating silent failures, which are plausible but incorrect answers, is paramount. Strategies include periodic human review, confidence scoring to flag low-confidence responses, and fallback strategies to redirect high-uncertainty queries to human agents. To optimize cost and latency, balance retrieval depth and model size. Cache results for frequent queries to avoid redundant cycles, and accelerate vector search using ANN indexes and GPU-powered databases for sub-second retrieval. Chapter 7 explores the future of RAG and beyond, charting where Retrieval-Augmented Generation is headed next. Emerging trends include agentic integration, combining RAG with tool-using AI agents. Graph-based retrieval uses knowledge graphs to handle complex relationships. Finally, the Model Context Protocol standardizes how models connect to live data sources. RAG is becoming the foundation for trustworthy AI. By grounding every response in retrievable sources, it enables auditable, cited AI outputs, domain-specific assistance, and enterprise-wide search unification. Enterprise RAG is now supported by major cloud providers like Microsoft and AWS, who offer managed services. These solutions accelerate adoption by providing customizable pipelines, integrated LLMs, and built-in security and monitoring. The AI assistant of the future will not only generate content, but also retrieve, verify, and cite its sources, consulting multiple knowledge bases in real time to deliver answers you can trust. Mastering RAG is key to grounded, reliable AI. It bridges the LLM knowledge gap, requires thoughtful design and governance, and should be scaled iteratively. Organizations that embrace RAG today will lead the next wave of trustworthy AI tomorrow.